you don't need your computers right now. So hands off the mice, turn off your screens, look up here. At some point, you might want to write something down in your notebook. Do you not have a notebook? Do you have a box? All right, back to me. We're going to talk about basic electronic circuits, and today we're talking about direct current circuits, DC circuits. So, uh, can you, number one, cover your nose, and number two, stop talking. Thank you. Thanks. So to understand, we're going to do these solar suitcases that there's one over here on the side. They provide emergency power. I held it up last week or the week before. They're made by a group called We Share Solar based in Berkeley, and PG&E funded our ability to use them in our class. So we're thankful for that. And you guys are going to get to assemble one of these suitcases in a couple of weeks. We're just learning about solar power and how it works first. Basic bottom line, what is electricity? Electricity is when electrons move inside of a conductor or a wire. You don't have to write all this down. I'll tell you when I think you should write something down. A conductor for us is usually a piece of wire, metal. And then conductors are insulated by plastic or rubber, something that keeps the electricity from going through. Those are called insulators. You probably have, maybe you remember when we connected those fans up to the batteries here in our class, they had, the wire wasn't just bare wire, it had plastic around it. So a circuit is a system of components held together by wires. So in this case, this example, we got a battery, and then a wire goes to a little clamp, and another wire goes to a clamp, and the clamps are connected to the light bulb. So that's a basic circuit. So a circuit has two key parts in our world: a load, which is what's using the electricity, and then a source. That's where the electricity is coming from. So in that circuit up there, the source is the battery, right? The power is coming from the battery, and the load is the light bulb. Just covering some basic terms. Can people come up with some other ideas for sources? What are some ideas you have for sources? Rocco? A solar panel. We got battery, solar panel. What else? It could be electrical source. A what? A potato, indeed. Very low power, but yes, somehow. I don't understand why, but they make power. Yes? A generator. A nuclear power plant. The plug in the wall where we plug things in. I mean, I know that's not really where the electricity is coming from, but that's a source for us. The 12-volt jack in your car, cigarette lighter. How about loads? What are some examples of loads? Yeah, these computers sitting on your desk, your smartphone, the laser cutter, anything you plug in, toaster, refrigerator, electric light. Here's some that are on this PowerPoint I got from the We Share people. Battery, nuclear power plant, solar panel, generator, carport. Check it out. Battery can be a load and a source. Not at the same time. It's a source when it's providing power, and it's a load when you're charging the battery. Just something to think about. So now we're talking about DC current. DC stands for direct current. That's the type of electricity that batteries provide and that we're going to be using in our solar suitcase. All of our electronics, almost all of our electronics, use DC current on the inside. You know how you have like a power brick for a lot of things? You have a power brick, and then like your Chromebook, there's a little thing, and then you plug a separate thing into your Chromebook. That power brick converts AC, which is what's in our wall outlets, alternating current, into DC, which is what all of our electronics use on the inside. So um, direct current has a positive side and a negative side. Like, I don't know if you remember when we had the batteries in the fan, there was a little plus on one side and a minus on the other side. Alternating current doesn't have a plus or a minus. In alternating current, the electrons go one way and then they go back and forth 60 times a second. They just go back and forth, which is kind of weird. But those are the two main types of electricity. The nice thing about alternating current or AC, the reason why it's what we have in our houses, is it's easy to send it over long distances without a bunch of power loss. I don't know why, but physics people could tell us. Um, all right, so if you cut any side of the circuit, then the light won't run, or the circuit is broken. We do that on purpose when we have a switch. This is a little solar panel, a switch, and a light. Um, uh, and then one last point, if you connect a power source to itself, that's called doing a short circuit, and that's bad. It can start on fire or destroy the device. So we don't want to short circuit a battery because it'll spark and probably destroy the battery and hurt somebody. So, all right, so I'm asking you right now in just a sec to go, I have to post the assignment, but we're going to go into Tinkercad and make a circuit. There's a circuits button on the left side of Tinkercad. You're going to make a circuit with a little solar panel. And then after that, you're going to go, you're going to take a few minutes to sort of brainstorm. What do you think? How would you make a toothpick bridge if you had 50 toothpicks and some hot glue? By the way, the bridge has to go across 10 inches of space. We're going to set up two like bricks and put the bridges on top, and then we have weights that we're going to put on top and see which bridge is the strongest. So I think I'm going to be stopping by Safeway to get some yerba mates for the prizes. So in case that incents you to try hard. So for now, let's have me post. You got to go, and they haven't come with a note. Go ahead. Yeah, it's all right. I get it. So I posted it, everybody. If you would open up the assignment, and I'm